I'm just rewriting the formula for your convenience. This much we had discussed in the previous class. All right. Now today we will start solving the questions based on it. Everybody has kept the formula in front of them. Let's try and use it to solve some questions, and then we will proceed to the next part. Right, first question. If y is equal to sine 2x, sine 3x, find yn. Whenever you get this kind of question, you can make it clear, or it is visible directly from the question, that what all formula we have discussed will not be used directly, right? You cannot use directly the formula. So what we will do, we will try to convert it in such a manner as you used to do it in integration. We have to shift it in the structured formula. So what we will do, you can always write y is, now see what I am doing. Any problem in this? And what is 2 sine A sine B? What is 2 sine A sine B?
Cos x
It is
minus cos
cos
5x.
A minus B minus cos A plus B.
Yes.
So cos A minus B will give you cos x, and cos A plus B will give you cos 5x. I'm writing it in one go. I hope it is clear to you. Which formula we have used? 2 sine A sine B. This is the formula. Now it is in the structure that we are looking for. If I have to find yn, so differentiating n times, yn is half dn by dxn of cos x Now we will look for the formula. Check the formula for cos. If this is for sine ax plus b and this is for cos, that is a to the power n cos ax plus b plus n pi by 2. Let's see. When you are focusing on cos x, what is a? A is 1. Right? See? Cos ax plus b. You have no b and a is 1. So you have cos x. So what will you get here? 1 to the power n cos x plus n pi by 2. Agreed? So we will write it as, this is half cos a x. So a is 1. So x plus n pi by 2. Minus, here your a is 5. So 5 to the power n cos, and this is your answer. Have you understood how do we use the formula? Please ask. We don't have this much time.
एक्सक्यूज मैम।
Yes.
मैम यहाँ पे cos x की जगह माइनस cos x नहीं आएगा?
माइनस कॉस एक्स क्या होता है? माइनस कॉस एक्स और कॉस माइनस एक्स?
मैम you have written half cos x minus 5 cos 5x
Just tell
using the
me.
formula cos a minus b minus cos a plus b.
Uh,
So
so what
ma'am,
is cos?
2x
What is
minus
cos
3x.
minus x? What is cos minus x? Tell me that.
Okay, okay. Sorry.
Doesn't matter what you take as a and what you take as b. Since it is cos of minus x is cos x only.
Yes, ma'am.
Okay, so that's why I have written it directly without specifying what is a for me and what is b for me.
Okay, ma'am.
Now write down the next question. Find the nth derivative of. Now whenever you find this kind of structure, the first thing that we have to do is to try and convert it in the known format. And what is known format for us? This is the known format, ax plus b to the power m time, right? Now in this particular part, if you focus, the degree of numerator is higher than the degree of denominator. So first step is we divide it, because until unless we split it in linear factors, we won't be able to apply the formula. So first step is divide it. So actually what you have, I'm writing it here. You have x to the power 4 divided by x square minus 3x plus 2. Just check, is it right? Now I
Yes,
want you
ma'am.
to divide and give me the output. What will you get?
Ma'am,
You,
15x minus 14 divided by x square minus 3x plus 2
hmm, hmm.
divided
So
by
I will write it
x
like
square
this.
minus 3x, okay, ma'am, plus x square plus 3x plus 7.
Very fast division you did.
Ma'am, it is in the assignment, so I have already solved it.
Fine. So this is the division. I'm writing it here. X square plus 3x plus 7 plus 15x minus 14. I'm not writing it in that part, product form, because I have to further split it. Is this division understood? Hmm? Now let us see how do we split it. This is the partial fraction part. So I want to know what will it give you. So let us write it here. 15x minus 4 is a x minus 2 b x minus 1. So when you put x is equal to 1, you will get, when x is 1, so a is minus 1. And when x is 2, then 30 minus 4, sorry, this is 14. This is 14. So 30 minus 14 gives you 16. So b is 16. I want you to please verify what I am getting. So now I can write y is equal to x square plus 3x plus 7 minus 1 upon x minus 1 plus 16 upon x minus 2. I want you to verify this, please.
It is correct.
Okay.
Yes,
Now
ma'am.
you have to find yn. Now you can see this will disappear, this will disappear, and this will disappear. Agreed or not?
यस मैम, इसी में डाउट था कि हम लोगों को स्पेसिफिक लिखना पड़ेगा ना कि n is greater than 2, that's why it is.
Obviously, when you are dividing, when you are differentiating for n is always greater than 2. Mention it. Okay? So if you want, you can mention it for n greater than 2. Yn is minus dn by dxn of x minus 1 to the power minus 1 plus 16 . Okay, now use the formula that we had. And what was the formula? We had written the formula for n is equal to minus 1, right? And that formula was, check your previous formula that was given to you. I'm not going to take it again and again. I'm writing it directly. Factorial n. Here your a is 1, so I'm not writing an, divided by x minus 1 to the power n plus 1 plus 16 minus 1 to the power n factorial n. Same formula, and you will get this. Okay, so you can club it by writing factorial n into minus 1 to the power n, and in bracket you will have 16 upon x minus 2 to the power n plus 1 minus 1 upon x minus 1 to the power n plus 1. Have you understood it? We had discussed the formula in detail, and it is expected of you to keep the formula in front of you to remember the steps. All right? The process is understood. Now let's try and move further. The first formula we did, the first question that we did was for trigonometric value. The second function that we did is for ax plus b. Now let's do the third type of question. Note down the question. Question number 3. Now you have y is equal to e to the power 2x sine cube x. Now here also, since it is sine cube x, you need to focus on how to make it linear. So for that we will use the formula of sine 3x. What is the formula?
3 sin x minus 4 sin cube x.
Sine 3x is 3 sin x minus 4 sin cube x. So we can write sine cube x as 3 sin x. Always remember this formula. It is very handy and gives a lot of relief. Right? Now substitute it here. So y is e to the power 2x. I am writing 1 by 4 outside. Sin x minus sin 3x. This is with 3 and this is sin 3x. Is it all right?
Yes, ma'am.
Now, which formula do we use? We can write it like this. 3 by 4 e to the power 2x sin x minus 1 by 4 e to the power 2x sin 3x. Now we will use the formula. Let's go back to see this formula. Note it down. y is equal to e to the power ax sine bx plus c. I hope it is in front of you.
Yes, ma'am.
So let's try and apply it. Now focus on first part. First part. This is the part. Now you are finding yn. So 3 by 4 will be as it is. E to the power ax will be as it is. Now what is a square and what is b square? A square is 2 and b is 1. A is 2 and b is 1. Is it okay or not? E to the power
Yes,
ax
ma'am.
sine bx plus c. So ax is 2, so it is 2 square. B is 1, so it is 1 square to the power n by 2 into ax into what else you get? Sine x plus n tan inverse b by a. So what is your b? B is 1. What is a? A is 2. This is first part. Minus 1 by 4 e to the power 2x. Now here your a is 2 square, your b is 3 square, sine 3x plus n tan inverse 3 by 2. Is this understood or not? Hmm? Speak up.
Yes, ma'am.
Yes,
Hmm.
ma'am.
So this is the way how we use the formula. Four plus nine is 13. Okay. There are many questions in which you will be using this formula directly. I want to take up one more question, rather two questions based on it. So let's try those kind of questions. Right, next question please. This will be fourth question, right?
Yes, ma'am.
So now your y is 1 upon x square plus a square. Find yn. Whenever you get this kind of question, the process is, we have not studied any formula on this. What we can do, we can always split in linear factor using complex numbers. Like I can write y as 1 upon x minus ia into x plus ia. Any doubt in this? Hmm? You can write iota a. When you multiply, it will be x square minus I square a square. I square is minus 1, so that will give you x square plus a square. Right? Now, we have to split it in linear. So what can I do? See, you can write it as x plus ia plus, sorry, minus x minus ia. I'm doing it using adjustment. You can use it a upon x plus ia and a upon x minus a. If you add it, what you are getting? You are getting 2 ia as extra. So what I'll do? I'll divide it by 1 upon 2 ia. Is this step understood? I've adjusted it to get 1 so that I can split it linearly. So I'll get, is this fine? This is a shorter way of doing it. Now if we have to find yn, we know how to deal with it. So if you have to find yn, this is 1 upon 2 ia dn upon dxn x minus ia to the power minus 1 minus dn upon dxn x plus ia to the power minus 1. And you know the formula. What is the formula? 2ia. The formula is minus 1 to the power n factorial n upon x minus ia to the power n plus 1 minus minus 1 to the power n factorial n upon x plus ia to the power n plus 1. This is a formula we just did in the previous question. Okay. Now the problem is, here what we have is in I, but the question does not contain I. That means we have to, what happened to it? Oh, it's all shifted. Till here you have no problem, no? So I am removing this part.
Just 1 second.
No. Noted the
Can you
answer?
scroll down?
Noted the answer? Till here? Now let me clear it. And I'm writing starting from the answer part only. So yn was minus 1 to the power n factorial n. I'm taking out the common thing. Here you have 1 upon x minus ia to the power n plus 1 minus 1 upon x plus ia to the power n plus 1. Till here we did. Okay. Now since this is not in the structure, we got the question and this I has to be removed. Let's try and use some kind of substitution. What substitution do we take here? We will take x is equal to r cos theta and a is equal to r sin theta and see what will it do. So when you write x minus ia, it will be r, the c cos theta minus I sin theta. Is it okay or not? And that is nothing but r e to the power minus I theta. Do you remember this?
Yeah.
Do you remember this Euler's formula we did?
Yes, ma'am.
And what is your r? R square is x square plus a square. And what is your theta? Theta is tan inverse a by x. Just remember what substitution we are using. It's not coming in, isn't it? Oh, leave it. Have you understood the substitution? Similarly, when we will write x plus ia, this is r cos theta plus I sin theta, which is r e to the power I theta. Remember this. So when you will write x minus ia to the power minus n minus 1, it is actually r to the power minus n minus 1 e to the power I theta n plus 1, and x plus ia minus n minus 1 is r to the power minus n minus 1 e to the power minus I theta n plus 1, which is nothing but r to the power minus n minus 1. What is this? Cos n plus 1 theta plus I sin n plus 1 theta. And this is r to the power minus n minus 1 cos n plus 1 theta minus I sin . Is this okay? Now we will be using this in the answer and see what you are getting. I'm using different colors so that you can see it more clearly. This implies yn is minus 1 to the power n factorial n upon 2ia. If I take out this r, can I write it here without any loss of problem? Without any problem? This r to the power minus n minus 1, I can put it in the denominator? Yes or no?
Yes, ma'am.
Now, because I have to club it, so I'm putting it in the denominator. And what I have here? Here I have cos n plus 1 theta plus I sin n plus 1 theta minus cos n plus 1 theta plus I sin. Is this fine? I put this value and this value here. So cos and cos will be cancelled and we will be getting yn is equal to minus 1 to the power n factorial n to I. Any doubt in it? Understood? Yes, class. We can cancel this I, and the answer that you are getting is minus 1 to the power n factorial n sine n plus 1 theta divided by a. Now r n plus 1 theta, sorry, r n plus 1, because r is also replaceable. We can write r as, what was our r? We can write r as a sine theta. It was like this, sorry, a is equal to r sine theta. It was.
Yes.
A was r sine theta. So r can be written as a upon sine theta. So if you put it here, a into a to the power n plus 1 into sine to the power n plus 1 theta. So this is the answer, right? We can write this. Where your theta is what? Where theta is tan inverse a by x. That's all. See, I've solved one such question, but there are many questions based on it. Like, I'll give you example and I expect you to solve those. There is one such question is y is equal to tan inverse x by a. You cannot, it's not visible in this manner directly, but the moment you find y1, it will be 1 upon 1 plus x square upon a square into 1 by a, which will give you a upon x square plus a square. So what is the difference between this question and this question? Just the multiplication of this a, nothing else. Right? Now if you have to differentiate, you will differentiate it n minus 1 times. That you have to keep in mind. So wherever you have n, it will reduce into n minus 1. Is this understood?
Yes, ma'am.
Now there is next type of question that is direct output of this is find a derivative of tan inverse 2x upon 1 minus x square. Then what will happen? You know this is the formula. Which formula? This is the formula for tan inverse 2 tan inverse x. You need to remember this. You did it in class 12th. You know this or not? That tan
Yes.
inverse 2x upon 1 minus x square is 2 tan inverse x. So it
Yes.
is y is equal to 2 tan inverse x. So y1 is equal to 2 upon 1 plus x square. Now here what is the difference between this and this? Here your a is 1, that's all. The difference between this and this is a is 1. So when you break it, you will break it as x plus I and x minus I. Rest everything will be same. This is y1, so you will differentiate it n minus 1 times. I am telling you all this because you can, by knowing one question, you can solve many such questions. Is this okay? Understood how to tackle all this?
Yes, ma'am.
There is one more question which I want you to understand. This is not directly from tan inverse, but it is by taking the derivative up to certain level and then proceeding for the nth derivative. Like there is a question, if y is equal to x log, then find yn. We have not studied any formula based on it, but we know that if we differentiate log, then it will come in some kind of rational function. Let's see how we go about it. If you find y1, what will it be? Like you can write it like this now. You can write it like this. Yes or no? Using log function. So
Yes,
when
ma'am.
I have to find y1, differentiate it term by term. This will give you x 1 upon x minus 1 minus 1 upon x plus 1 plus log x minus 1 minus log x plus 1. Now in this case, though we are able to get first term which we know the formula, but second term is there which we do not know. So what we will do, we will differentiate it one more time. Are you getting what I am saying?
Yes, ma'am.
So if you will find y2, see I'll show you it at two different stages. Just a minute. You know how to deal with it, right? So let's make this portion as capital Y and this portion as, let this be y1 and this be y2 this way. Okay, now when you are finding yn, that means you are differentiating it n times, right? How many times will you differentiate? N minus 1 time. So you know how to get it. Is it fine or not? Hmm? Class, are you understanding what I am saying? Hmm? See, respond, otherwise it is very difficult for me to make out.
We have to differentiate each term in different steps.
Separately, yes. It's not necessary that you do it separately, a different step. If you can understand what you are going to do, then it is easy. For example, if I am writing y2, I'll split it for you. What will you get here? See, this is x upon x minus 1. So what will be the derivative? The first thing is you have to see what I am doing. I hope you can correlate. What I did, are you able to understand? It is only adjustment. I am not differentiating. I'm just adjusting. Is this part understood what I did? Hmm?
Yes, ma'am.
Are you able to understand?
Yes, ma'am.
I have adjusted this plus this as it is. So this will give you 1 and this will give you minus 1. So 1 and minus 1 is cancelled. And you have 1 upon x minus 1 plus 1 upon x plus 1. This term is separated like this. We know how to get its inner derivative without any problem. Right? Now when you focus on this, you can differentiate it n times without any problem, but here you have log. That means first you will differentiate it for the second derivative, then you will get, see, one time derivative will give you 1 upon x minus 1 minus 1 upon x plus 1. Okay, and you differentiate it n times. That means n minus 1 times. I'm doing it in 2 steps. I'm writing it like this. Is it okay or not? For this, is this okay? Just see if you can understand or not. Have you understood what I did? I'm repeating, listen carefully. You had y, you differentiated it once. Are you listening? Please mute yourself. Please mute yourself. Somebody has noisy surrounding. Hmm. First, I have differentiated it this one time. So I got this part, 1 upon x minus 1 plus 1 upon x plus 1. All right. And here I got in log. Now if I have to find yn, since y1 was already there, by differentiating it n minus 1 times, we will get yn, right? Is this part okay or not?
Yes, ma'am.
Now for this, we have to differentiate it n minus 1 time, but since it is in log, I split it in 2 parts. First, I'll differentiate it once more, and then what is remaining with us is n minus 2. So I'll differentiate it n minus 2 times after getting this part. Now is it okay?
Yes, ma'am.
Yes, ma'am.
This was something I wanted you to realize and understand. Sometimes the question can have different aspects and we may need to differentiate it at different level to get the nth derivative. So like in this part you are differentiating it using the formula n minus 1 times, and here you will use the formula after differentiating it 2 times to get it in the structure of the formula. Now what is the formula here? The formula is for ax plus b to the power minus 1. So what will you get? I'm just writing the formula minus 1 to the power n minus 1 because you differentiated it n minus
Excuse
1
me, ma'am.
times. Yes,
Excuse me, ma'am.
yes.
Ma'am, when we have done y1 first time differentiation, we got x into 1 upon x minus 1 minus 1 upon x plus 1.
Plus this part also. Use product rule.
Yes, ma'am. In the first part, what you did, I am not getting that, ma'am. After that x minus 1
You,
upon x
you
minus
need
1
to
plus
remember the
1.
partial fraction thing. You got this, right? They have same degree, so you will divide it. Whenever you have linear, like for me it is easy if I write like this. I did this, right? So it will be split in two parts, x minus 1 upon x minus 1 plus 1 upon x minus 1 and minus x plus 1 upon x plus 1 minus 1 upon x plus 1. Is it okay?
Yes, ma'am.
I write the formula now. So this will be x minus 1 to the power n. Why am I writing n? Because you are doing it till n minus 1 times. So here you will get n minus 1 plus 1. I am writing it like this so that it becomes clear to you. Okay, for this. Same thing you will this for this, but let's do it in two steps. This is this part. Now when you come to this, you are differentiating it n minus 2 times. So remember that. Now I am writing it n minus 1. I'm assuming you can understand. Have you understood what we have done? Directly applied the formula for the derivative that we are looking for. Now please summarize it and see what the output you are getting. Whatever is the lowest value that you can take as common and then summarize it. Like for x minus 1, you take this and this. The lowest value is minus 1 to the power n minus 2 factorial n minus 2, and the denominator that you are getting, we will write it inside. Here you will have 1 upon x minus 1 and here you will have 1 upon x minus 1 to the power. See, you have 1 upon x minus 1 to the power n plus, you will get what else you will have here? Since you are taking out n minus 2, so you will have n minus 1 also, plus 1 upon x minus 1 to the power n minus 1. Is this fine or not? Plus do it for the second part. Now this simplification I am leaving for you. I want you to solve and give me the final output. Please solve. Please simplify and give me the final output. Done? Hmm? Last respond. Now I'm clearing this and writing the answer. Please match your answer. The answer that you are getting will be -1 to the power n minus 2 factorial n minus 2 in bracket x minus n upon x minus 1 to the power n minus x plus n upon. Just match your answers, please. So there are three things that you need to remember. The first thing is sometimes direct formula gives you the answer. Second, first derivative. Third thing, partly first derivative, partly second derivative. Even possibility is there that you have to do it till third derivative and then you go for nth. So partial differentiation, that is also possible. The second aspect that you need to do is sometimes you have to use de Moivre's. You have to use partial fractions to convert it in the format that you are familiar with. Third thing, trigonometric transformations. Trigonometric transformations are also important. So the thing is, you will revise this, you will revise this, you will revise this. And there are only 5 to 6 formula. You should always keep those formula in front of you till you are able to remember them without any mistake. Is this okay? Anything you have to ask in it? Like, do memorize what is the connection between sine 3x, cos 3x to their linear counterparts. First part. Second part, sum and difference of the trigonometric ratios. This is also very important. Third part, inverse trigonometric functions formula for tan inverse 2x, tan inverse 3x, sine inverse 2x, sine inverse 3x, and so on. All these are treated in intermediate steps, so you should know them. Is it all right? Huh? Ask if you have any doubt in it. Hmm? No problem? Class, I'm not getting any response.
मैम वो कौन सा थ्योरम लिखा है आपने?
कौन सा थ्योरम? कहाँ पर? De Moivre's theorem. That e to the power. De Moivre's theorem you have studied in
Ma'am,
class
which
12th.
theorem have you written?
This part. I'm not able to make out which part you are saying. Partial. This is De Moivre's. This is partial. This is trigonometric transformation. Are you asking something other than this?
No, ma'am, fine.
Okay. So this is all for the formula part. From next class, we will be starting with Leibniz theorem. All these formulas and questions are already uploaded in PPT form and its audio file. I expect you to go through that and come prepared in the class.
Excuse me, ma'am.
Yes.
Ma'am,
Yes.
yesterday you said that the next assignment has been uploaded and we have to do the questions that we can do now. But where is that assignment?
Is it not on LMS?
It's on LMS.
It's
Thank you.
there. It's there, ma'am.
It's in LMS beta. Discuss with your class. They
Ma'am, it
know.
is an element.
When I have to get it submitted, I will upload it on Google Classroom. Alright? It is uploaded in the form of a folder in your LMS portal, on your LMS portal, so that you keep on solving during the teaching time and it saves your time and your pressure. Because if it is uploaded in the form of assignment, you can't do it every day. Is that fine?
Yes, ma'am.
Now I want you to focus on attendance, please. Start marking by the time I open this.